Hello, we've got another lovely Project Euler problem. This time it's number 11. So the problem is, in the 20 by 20 grid below, four numbers along a diagonal line have been marked in red. The product of these numbers is that number, 1,788,696. Oh, that needed a breath. And then the question is, what is the greatest product of four adjacent numbers in the same direction? Up, down, left, right, or diagonally? Okay, cool. So I think what we're going to do with this one, as usual, is use some sort of brute force. But before we do, let's try and work out like how many combinations of things we would have to check in order to justify using this brute force. Um, so clearly, in a sort of 20 by 20 grids, there are 20 rows and 20 columns. But the question then is, how many diagonals are there? And I think this is probably easier to see if we consider a smaller grid. So let's do that. Earlier today, someone introduced me to this wonderful password game, and I'm basically using it as a way to get a picture of a smaller grid. The password game is quite fun. I mean, it starts off with some pretty standard password rules, and it just slowly gets more and more ridiculous. I really did have to go away and solve today's Wordle. Um, for that one, I just googled like phases of the moon, but oh my goodness. But the reason we are here is because I want as a picture of a chessboard, and I figured out what the optimal move was. It's queen to here. Let's get the king in check. Good old queen sacrifice. Anyway, what we want to do is count the diagonals of a sort of 8 by 8 grid. So I think it's a bit easier to see with actual squares. So if we do diagonals that sort of start on the left and end on the right, we've clearly got this like one long diagonal, and then we've got two of these dark coloured square diagonals either side of it, and then we've got a further two of these light colours diagonals, a further two of these dark ones, and so on. So I think if you've got an n by n grid, then the number of diagonals in a given direction is going to be 1 for this long diagonal, and then another 7 diagonals that start here, 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 and here. Now, if it's an n by n grid, like I was saying, it is be sort of n minus 1, and then a further n minus 1 that start here, 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 etc. So we could maybe even put this into a function. So just because it's a nice way to express things, I guess. Like we're not actually going to use this in the solution, but you know, oh well. So it's just going to be, like I said, 1 plus 2 times by n minus 1. But remember, that's only in this direction, from sort of top left to bottom right. We also need to consider diagonals in this direction. I don't know how illustrative me moving the mouse cursor like that is, but it's just going to be, it just means we need an extra factor of 2. So the number of diagonals is sort of for, I mean, we can work out what this is for 20, right? Because we do have a computer. So there should be this many diagonals. 78, which is quite a lot actually. Okay, cool. And then I guess what we can also think about is we'd want to add to that the 20 columns and 20 rows to figure out the number of like collections of numbers that we're checking. Now this isn't even all possible sets of 4. We're going to have to do something else to get all possible sets of 4. And there's a function that I think I used in an earlier problem that's going to be really useful for us, called sliding. So yeah, let's go ahead and start that. So let's imagine that we've parsed this grid such that we have all possible sets of numbers that we want to check. That is, we've got all of the columns, rows, and diagonals nicely on lists for us. And then what we want to do is find the one that's got the maximum products. So let's do that. I can't think of a better name than just solve, because I'm really bad at naming things. Also, I can't spell. I'm sorry. I can't diagnose. No, diagonals. I can't spell. Okay, so let's imagine that we've got a list of lists of numbers. So lists of numbers probably could do with a better name, to be honest. Um, like fuss. And then what we want to do is for each of those lists, we want to generate sets of fours to be interested in. So because of that, it sounds like we're probably going to want a four comprehension because we're kind of like we're turning we're generating more things from our input essentially. So I can take an individual list like this just from our lists of numbers, and then for my individual list, I want to generate a combo of four. And we can do that with the magical function that I mentioned before that's called sliding. And we will want to use camel case, and we'll want to yield out our combo of four, like that. But what we actually care about is the products, so we'll just do dot products because Scala is nice and has dot products for us. That returns an iterator rather than a list. So this whole thing overall is going to return a list because we're starting off with a list. So I think Scala's got some like magic implicit thing that's going to, go ahead and convert this iterator into a list for us. And then what we actually care about is the maximum of this. And in Scala, that's just max, I believe. So I think sliding, I've explained it before, but just very quickly, it's just gonna, oh gosh, that font's really quite small, isn't it? It's just gonna give us like twos if you call it with two. It'll give us triples if you call it with three, and it'll give us quadruples if we call it with four, which is what we're doing. Also, from the documentation, it looks like if you call it with something that's kind of too big for the list, because this is a list of one item, it's going to give us back something containing one item, which we don't want. We want to make sure that they're always four items. So we need to make sure that like our combo of four really does have four items in it. So we can do that like that with a little filter. So this solve kind of assumes that we've passed this grid. So, let's go ahead and pass that grid. We can also check if I was right about the number of diagonals thing as well. So, yeah, let's give that a go. Alright, let's do the grid passing. So, we have our grid, which at the moment is just, I think it is just a string. I hope it's just a string. Yes, it is just a string. Okay. So we've got our lovely raw grids like this, and we need to extract the rows, columns, and diagonals as lists of ints to sort of feed into this solve function that I've got. So let's see how we can go about that. So what I usually do with these things is I index it using just x and y coordinates, and then for the rows and columns it's dead simple. It'll just be everything that's got the same x coordinate is just a column. This is the sort of x equals 0 column, this is the x equals 1 column, this is the x equals 2 column, and likewise if you're that's your y equals 0 row, y equals 1 row, y equals 2 row. I think the thing that's a bit trickier to kind of figure out is how do we like grab a diagonal from this, and I'm going to go back to the chessboard actually, and I think the way to do that is this line here. If I was just doing maths, that line is y equals x, right? This sort of light colours diagonal, that is just y equals x plus 1. This is just y equals x plus 2, and so on. So diagonals that look like this like y equals x plus some constant, and that constant determines which diagonal you're on. So let me write that down because I'll forget otherwise. So y equals x plus c. And likewise, diagonals that go this way, well, this line is going to be y equals 8 minus x, right? This line is y equals 7 minus x. This line is y equals 9 minus x. So that is y equals, I'll just use c again, minus x. Therefore, what we want to look for these ones is things that have a constant y minus x. Like I've literally just rearranged an equation, right? And for this one, we want y plus x to be a constant. I hope that makes sense. But let's see. So anyway, the first thing to do is like try and get this into coordinate form. So I think we can do it using what's it called? Is it split? In JavaScript, it's split, isn't it? There's like split and join in JavaScript. So I think you can do it with regex, but regex like really scares me. We can split it with new line characters for sure though. I don't know if you can do a literal like new line as a character, but you can probably do it as a string, right? Yes. Good. Okay, so that'll give us, I think it'll give us an array of strings. I prefer to work with lists, so I just find it slightly easier. But let's check. So that's going to give us, a list of strings. Great. And then for each of those lists of strings, we want to split those kind of by white space characters, right? Which just looks like that. And again, let's take it to a list. So we now, what we'll have essentially is like nested lists, but you'll remember that I kind of wanted to assign numbers to these, and the way to do that in Scala is good old zip with index, and I think you can do it here as well, and this will return as something fairly horrendous, but we can flatten it. So a list of, so that's pretty horrible. So I think the way to do this, again, is going to be a full comprehension. So you can have a sort of, I guess you can have, would it be a row if you split it by new line? Yeah, absolutely. So you can have your row like that, split by sort of new line, and then your column is going to be just your, well, it's not really a column, is it? It's just a sort of value, I suppose. Split by this new line character, like fuss, but I wanted to, I wanted to get the index in there as well, didn't I? So I think we can do zip with index, like that. So this should be a list of, string ints. Or, well, no, a string with an int, because we're going to split a string, aren't we? And this should, again, be sort of string int. I'm not really sure why it's not telling me what type it is, but I think in Scala 3, I think you can just, like, so row and split I think this just works without the compiler plugin, without that better monadic for plugin, but I'm not sure, actually. And then we'll use a j-index here. And, like, I hope that's, yeah, so it's inferred it now. I'm not sure why it wasn't doing it before. And then, because I'm a sucker for case classes, let's just sort of do this. So it'll have, I've called them I and j there, but I suppose I should call them x and y, because that's kind of what they what they are. And then the value, which is also going to be an int. So you would do square with sort of, so rows correspond. It doesn't really matter if I get my x and y mixed up, so I'm not going to pay too much attention to it. So you do x, y, and then value like that. And that should be us, I think. I don't. Yeah, that's why I've called it a square. So okay, cool. Um, let's go ahead and use this in the main code and see if it works. So I want to pass the grid of my big grid. Let's see what it does. Yeah, yeah, that's kind of fair. I think it just has two ints. I don't know if it's safe to use, but so that might still throw exceptions if I've got it wrong. I think my IntelliJ is just being a bit naughty and not telling me about things. Okay. 4 input. So that's a number format exception because of that. Oh, I've probably got too many quotes. You see, I got 4 quotes there. Oh dear. Okay, so it's past it. So you've got 00 is 8, 01 is 2, yeah, 02 is 22. So it looks like it's parsed it correctly. Great. Okay, let's use these equations, and they're just sort of like, so these are for diagonals, and remember the other ones were just like y equals a constant for either rows or columns, I've already forgotten which, and x equals constant for either row or column. One of these is rows, one of these is columns. I just can't remember which way around it is. Alright, cool. Alright, so let's find a way to select the different rows and columns. For rows, it's gonna be... Oh, this needs a name. So squares, because they are squares in the grid. As we said down here, for rows, I think it's going to be constant y. So if y equals, I don't know, 0, it's the bottom row. So yeah, so we want to do our squares, and we want to group them by y. And this is going to, of course, give us a map from... No, I think that's fine. So I've just thought of something that I'll talk about a bit later, but I think it's fine. And it gives us, a map of this is the y value selected, therefore this is a column, and this is a list of squares in that column. The concern I have is what is the sort order in that list going to be? Because obviously, for the problem, what we actually care about is like, if it just gave me a column or a row rather or whatever with the things scrambled up, it's obviously we won't be able to get the right answer in the end. But I believe the way in which group by is going to work is because it's going through the collection sort of one by one, it will preserve order. And by the way that I've parsed the grid, I think the order is going to be preserved. But I think if this was like actual, production code and all that, I would test the hell out of it. But, it's just a project with a solution, right? So, it's just for fun. So, we've got our map. We only need the values, right? And that's going to give us an iterable of a list of squares, which is what we want. Each entry in that iterable is an individual row. And so what we need to do then is look at, well, we're returning a square, but we kind of don't use the x and y information, and this little solve function expects a list of ints. So instead of using group by, let's use group map, which also gives you the sort of power to like map something, map the entries that you're grouping, right? So that's now sort of the correct type. I suppose I could either change that to an iterable or do a to list here. Either of those is going to be fine. So for columns, it's a similar story. Cols, just because it's got the same number of letters. And then likewise for sort of some of the diags, we'll do sort of because I usually call stuff x, but I don't want to do like x.x, so we'll call it s because it's a square. So I think one of them has the added together, and I think the other one has them subtracted, doesn't it? Yes. And then again, this is the sort of thing where it's like, to me, like this group map is kind of dangerous because I don't know if it's actually getting them in the right order. I think it is, but just from the way that this has been passed, it's been passed in an ordered way. And then what we want to spit out is the kind of like all of these things concatenated together. Does iterable have plus plus on that? I don't know. I think it does. Cool. So we can kind of plus plus these guys together. And I'll maybe go ahead and run this function, but the other thing that I was interested in counting was is the number of diagonals what I think it should be. So let's see. So if we do that one, length plus this one. So we'll just print that out, nice and easy. So we'll do our sort of parse grids. Yeah, we're already doing it, great. And then I can't actually remember what the what that number was before, so I'll have to print that out as well. And hopefully it's the same. Let's see. Length is not a value. Length is not a member. Okay, so it's probably size, right? Cool. So they're both 78. So I was right. Well, that's reassuring at least. Okay, cool. So we don't use that print statement anymore, and I think it's probably most straightforward, just for the sake of getting this solved. This returns an iterable. So if I just do as that, just so it's a bit more clear, and I'm just going to go ahead and line this up. I think it'll all still work, and then we just want to solve like this, and that'll hopefully give us the answer. And I think my sort of projects, no, it's the wrong one, isn't it? So we want to use solve on this. And I think my timer will just print out the answer for us. And also tell us how long it took, obviously. So, you know, what's that, 50 milliseconds? Not bad. Especially if it's the right answer. I mean, it's bigger than that number. So it's probably correct, isn't it? Cool. The confirmation code I entered was incorrect. Fair enough. I guess I'd opened this like way long ago. Yay! Alright, so that's how you do that one. I think this video is probably a bit too long, but I think it's quite nice just to show the sort of missteps that I've made, to be honest. And I guess the other thing to say is, like, you might have noticed this fella was open in the background, and this is like my solution from, I guess, a year or so ago. Probably. So you can see this is from like 2021, so I have like almost no memory of this, and it's a bit different to what I've done today. I sort of glanced at this before I went ahead and did the solution today, but I was making it mostly, to be honest. But yeah, it's pretty similar. Actually, that's a bit more efficient than what I was doing it, right? Anyway, and also, you probably don't need it in practice. You probably don't need that filter in practice because you're looking for the maximum. So I bet it gives you the same answer anyway, because when you take the products of a smaller number of things, it's going to give you a smaller number, right? Always. It has to. So it's sort of technically necessary, but kind of not really. But yeah, and like, I think for sure when I was doing it the first time, I don't think I was thinking about this, because I think I use the same thing, right? I think I use the group map. I imagine I do. Yeah, so I don't know if I'd properly considered that sort order stuff. I think I'd probably just like written something that works. So that's interesting. So I've certainly, I guess I've come a bit of a long way since 2021, but anyway. Yeah, yeah. Well, thank you for watching, and good day. Goodbye.